All right, so this is week 3, day 3. Okay, so this is actually the last lesson that we're going to go over for the CASP practice because tomorrow you guys will take a practice test. So you're going to need a computer, one of the ones that I have here, if you don't happen to have one. But you're going to need your computer. And then Friday is going to be kind of like a free day like we did last week where you can finish up homework, you can finish up your Delta math, stuff like that. Okay. Then next week, I think I mentioned to you guys, is just consistent testing all the week. Okay, the whole week, consistent testing, just to let you guys see the remainder of the stuff that you have to know how to do. But remember what I told you, the reason why we're not going through those in more detail is because those, altogether, those 4 tests only make up for about 10% of the exam. So it's not that much. Okay, the meat of the exams is what we've done in the last 4 weeks. Okay, so that's why we spend so much time doing this stuff versus next week you're going to see just real quick. I'm just going to let you see it in the test form. Yeah, after this, well, after we're done with this week and next week, then we'll start off going back to doing the arithmetic series, geometric series and stuff. The reason why we didn't do, so if you remember, we did section 8.1, 8.2, and 8.5. And I didn't do like 8.3, 8.4, 8.6, 8.7, because series are not part of the state test. Sequences are. So that's why I wanted to make sure we did sequences. And you saw that yesterday, right? Sequences is what we practiced on. But they don't do series, so I didn't have to teach that until after the test. So yeah, we will go back to normal lessons and stuff like that once we're done. So, all right. So like I told you guys, for this section right here, we do not need to take notes or anything like that. You can always look at this for notes if you want. But this assignment is going to be done on quizzes. Okay, so let me just kind of show you a couple of these examples. And like I said, you don't have to write them down, but just kind of look at them. That way, when you see them on quizzes, you can be like, "Oh, I remember we did that one." The main idea of this is like they're going to give you a situation. You're going to tell them which one is the right answer. So number 1 says choose the graph of distance as a function of time. Okay, that means this is distance. Whoa, I'm using a highlighter. Hold on. So this is distance and this is time. Okay, distance as a function of time. This would be distance, time, all the way through. So choose the graph of distance as a function of time that matches the situation. The situation is riding a Ferris wheel. The rider's distance from the ground is what they're kind of trying to show you. So what do you guys think? Which one would be the one that makes the most sense as to riding a Ferris wheel? C or B? So for B, let me see. We get, well, hold on, let me look at B. So that one's circular, so we think Ferris wheel, right? So as time goes on, I go further up, right? And then I go back, but then it kind of in order for me to go backwards, that means I have to go back in time. And I can't do that, right? We can't travel back in time. So I can't do this one right here, because this means that I traveled backwards or traveled back in time. Right? So that's not good. And then you said C was another option, right? So for part C, I started at a certain point, and then as time went on, I went further away, but then as time kept going, then I came back to like a same distance, right? And then I went further away, and then I came back to the same distance. That's kind of what a Ferris wheel does, right? You start here at the bottom, and then you go up, and at a certain point, you're as far away as possible, but then you start to come back to the starting point, right? So even though a circle makes sense in terms of a picture, but it doesn't make sense in terms of traveling backwards in time. But C does make sense. Now, what would be the difference between A and C then? Because those are kind of the same. Why wouldn't I pick A? Because A kind of looks like I'm going up and then back down, then up and then back down. What about my distance? So too high, give me more information. I like where you're going with it. Well, we're way above the ground. Where do they normally load you in? On the ground. So they're not throwing you up on the top, right? They're not just launching you up there and say, okay, this is where you're starting, right? You are going to start lower to the ground, then you'll go up and down. I guess maybe there's a situation where part A could be true. Maybe they take you up in an elevator and then that's where you get on your right, right? But for most cases, it's going to be probably C. Okay? So there you go. Notice we're not having to do any like math in a sense of like, let me calculate this, but you're trying to reason, right? You're trying to reason. So let's look at another one really quick. Let's look at number 3. Choose the graph of distance as a function of time that matches the situation. So distance, time, distance, time, distance, time, distance, and time. Okay? Riding an elevator to the top floor, stopping on each floor. So see, that kind of looks like it makes sense, right? Because A looks like I rode the elevator, I stopped, but then I went back down. And then I stopped, and then I went back up to the same place. Then I stopped, then went back down. So it's not A. B looks like I rode the elevator up, I stood there for a long time, and then I went back down. Okay? C looks like I went up, stopped, up, stopped, right? And then D looks like I just stopped on a specific floor, and that's all I did. I was stopped. So yeah, C makes the most sense for this one. Okay? So again, notice it's not like math work. You're just trying to think mathematically which graph makes sense. Now let's kind of skip some of these. Look at this one. Okay, E and F stand for Edward and Frank, okay? But it says choose a sentence that best fits the graph. So distance as a function of time, E and F. So part A says Edward and Frank walk 2 different distances to get back home, and Edward gets there first. B says Edward and Frank leave at different times and arrive at school together. Edward and Frank leave at the same time from school, but Edward gets home first. And Edward and Frank leave at the same distance from school, but Frank gets home first. What do you guys think? See? Edward and Frank leave at the same time, but Edward gets home first. That makes sense to me, right? Because they were both the same distance here, and let's just call it time 0. So they both were at the same distance when time was 0. As time started going, they both traveled the same distance. The only difference is it took Edward less time than it did for Frank to get that distance to 0. Right? So Edward was faster. So there you go. Okay? Again, no calculations. You're just thinking about it. Right? Just thinking about it. So there's more like that. Look at this one. Which runner started out fastest?
Charlie.
Charlie did, right? Because you can see in the very beginning of the graph, Charlie's, which is this one, is above all the other 2, right? So you can see that Charlie's graph right here took off a lot quicker than the other ones. All right? So which one started out faster? Well, it was Charlie, right? They'll ask you which one stopped along the way. They'll ask you a lot of different questions. So you notice there was one up here with the same picture, right? Which runner stopped for a rest? Which runner started out the slowest? Okay? Which runner won the race? Which one won? Albert did, right? Because he finished fastest. Right? Maybe didn't start fastest, but finished the fastest. Okay? So I'll put the answer there first. Now we'll keep going. So John is traveling to school. At what segment is John not moving? C, right? And that's because notice it's distance. Vertical movement is distance, and during segment C, that vertical segment is just flat, so it's not going anywhere. He's not going up or down or farther away, closer. He's just staying steady, right? So again, just kind of look at that. Again, not hard to do. Okay, and there's a couple of questions on that. Let me zoom out really quick. So you can see a lot of questions on that, like when is he coming back home from school? When is he leaving? Stuff like that. Give me a second. Let's check this one out. There's 25 of these, by the way, okay? So that's why I'm not too worried about doing too many of them. Number 16 says the graph displays the speed Callie rides her bike through the neighborhood. Which statement describes the graph? Okay, so it says Callie increases her speed at a constant rate, then slows down, then continues at that rate. Okay, then it says part B, Callie travels at a constant rate, then slows down as she goes uphill, then speeds up as she goes downhill. Part C, Callie is stopped at a stop sign, then increases her speed as she goes downhill, then decreases her speed as she goes uphill. And last one, Callie travels at a constant speed, then speeds up as she goes downhill, then slows down as she goes uphill. Say again? B? I think it is B, right? Because constant speed, that makes sense. The flat line, right? So speed's not going faster or slower, it's just whatever it is. So it's constant speed. Then the speed goes down. So there's a slowdown. So they say, well, she starts to go uphill, right? And then they say, well, then she speeds up as she goes downhill. So yeah, as time goes on, her speed starts to increase. So maybe she's going downhill, right? So this one makes sense to me. It's going to be B. All right. The main distractor that they're trying to mess you guys up with is looking at hills. Like some people will say downhill, uphill because that's what the graph looks like, downhill, uphill, right? But you got to remember that's not a distance over time or anything like that. It's not the altitude over time. It's speed. So when you go uphill, you don't tend to speed up in most cases. I mean, maybe in a car you can, or you can just push the gas in. But usually if you're running or walking, you tend to slow down a little bit, right? So, all right, let's move on. Like I said, there's more of these. But I want to get to the last set. And I know which ones are the last sets because they look like pictures. Here we go. So this is the only thing that I'm going to tell you might want to take notes on just for an equation, okay? Just for an equation that I'm going to write down for you guys. So they give us this picture right here, and it says, let me try to move this up a bit. So U.S. movie prices over 20 years, they give you a graph and then they give you a chart. Now to be honest with you, this graph doesn't really matter. So I'm just going to kind of like get rid of it. Okay, let's not worry about that. We want to look at the chart. Okay, it says the average movie ticket price in the U.S. are represented in a table and a graph. Based on this information, what value is closest to the average rate of change for 1990 to 2010? So the average rate of change in math, we call it the AROC. Okay, so average rate of change. So we call it the AROC. Okay. You already know this formula, you just may not know it by this name. But what does this look like here? Anybody remember that formula name? That's your slope formula, right? Just that in the AROC, we don't write it like that. In the AROC, we write it like this. But it doesn't matter, okay? We're just going to use y's and x's. But just so you can see, this is the way we write it out normally. It's f of x sub 2 minus f of x sub 1. And actually, in calculus, we call it f of b minus f of a over b minus a. It's the same thing, okay? It's just the slope formula, okay? But this is the formula that I want you guys to remember because it's easier. It's whenever they say average rate of change, just think slope. Okay, so they gave us two dates, those two dates. So I'm going to focus on this information and this information. Okay, there's my x and my y, all right? This is my x value, this is my y value. So they just want me to find the slope using those two dates. 1990 and 2010. All right, those are my x values. The y values are $4.22, $7.89. So all I have to do is find the slope using those 2 points. All right, so I'm going to write them down for us right here. just so that you can see what I'm doing. So 1990 was $4.82. I'm not going to use the dollar signs. And then 2010 was $7.89. And I'm going to find the slope using those 2 points. Okay, so AROC, average rate of change, is y2 minus y1, so 789 minus 482 divided by 2010 minus 1990. If you plug that into your calculator, you're going to get about 0.18. It's like 0.183 something. Okay, so my answer is D. It's increased 18 cents per year. That's the average. 18-cent increase per year. And there's like 3 or 4 of these types of problems. Same idea. They're going to give you a chart, and they're going to say, find the average rate of change. Okay, so you can see right here, the average snowfall. So the average rate of change, so average rate of change of the snowfall, right? So they'll tell you 1 p.m., 6 p.m., so you'll use this and this as your X and Y's, right? So it's not that it's difficult to do, but you are going to have to actually calculate for that, all right? And notice there's more than just one, so I think the rest of them are like that. By the way, when you get to this, it says, what is the average rate of change for the number of fish caught between 2 and 5 weeks? What you're going to do at 2 weeks, you're going to write the point, 250. And at 3 weeks, or 5 weeks, sorry, you'll write the point 590, okay? And then from there, now you have your 2 points. Just use the slope formula and you're good. So if they don't give you a chart, but they do give you a graph, use the graph to figure out the points, and then from there, just use your formula. So it's not that it's much harder, it just looks different, okay? So let me give you guys the assignment, but this is all you're doing. Like I said, minimal math work. There are some problems near the end or at least 4 or 5 problems where you're going to have to actually calculate something, but not too many, okay? Let me assign this to you guys via quizzes.